quality of our software. We need to do that, so all the developers are aware of it, but I still have to see it really progressing. And another thing that I think is in the works is that the CogDoc tool that helps you make a documentation of your own Cog development from your sources does not work well, so there is a plan to improve that. So I think it's of interest for quite a few of you. And I think that's about everything. So if you have any questions, I may not be able to answer to everything. I accept checks and all currencies of the world, except for Bitcoin, because I don't trust it.
That's true. So any plan for tactic language?
I am sure that people want to change that. And I know I don't know what you know about the current setup, but there is Metacoq, which provides a way to look at all the data that are inside the Coq code, but look at them directly from the Galena language. So this is one way in which it will make it easier to do a lot of processing by writing directly Galena programs. There is basically what I'm not directly involved in this, but what I hear when I listen to the developers is that most of the time they are dissatisfied with the LTAC language, because there are too many things in it that are not clearly defined, and we have a documentation which is very weak, and so that makes that people discover some behaviors and then they get attached to it. But because we didn't write it in the documentation, we may change it. And so that happened in the past. I think we had some frictions with Adam, friendly frictions with Adam Shripala about this kind of things, because he was using things that we thought we could not maintain. And so on the one hand, it's really important that you have all this automation to make, because the perception I have is that what you are doing actually, the PIs of DeepSpec mostly, is you're developing domain-specific proof languages. And it's very important to be able to do that. So we want to do that. So now, if you look at what is happening, you have LTAC, for which we just try to make sure it doesn't break tomorrow. And then there is LTAC2, and as its name suggests, it just tries to provide an improvement over LTAC. It's not the definitive answer. It is something that reuses most of LTAC, but with a much better design principle. I think the design principle is that we want to have a language which is much closer in its in understanding its operational semantics, much closer to OCaml. So that's LTAC2. But then there are other efforts. You have this Metacoq that gives you access and makes it possible to use Galena. And there's also, when you look at the way of working of tactics, there is the SSReflect experiment that also showed that there were a lot of uniformity that could be gained in the way some tactics worked. So this is a source of inspiration. But right now I cannot say that we know what is going to come out of all this. I can just say LTAC, because in all its unknown qualities has to go because it's too unknown. LTAC2 is an improvement on that, but we don't guarantee it's the final solution. We know it's not the final solution. It's just a way to make things cleaner right now. That's a temporary solution, I believe. And what is to come after that, well, is going to be the result of discussions. And in fact, these discussions are not so easy because some people are attached to some ways of doing, and sometimes the discussions don't revolve only on technical reasons, but sometimes on more or less avowable reasons. So I can't say much more about this. I can just say LTAC2 is something that you can use now because it's much cleaner and you can try with it. I cannot guarantee that whatever you're going to do with it is going to stay as it is for a long time. But it may be a good way, because it's going to be cleaner, it may be a good way to do experiments that will be easier to port to another better design language later. Another question?
Probably started, you told something about it, but can you comment a bit more? So, since Coq Consortium started, you do now things in a very good way about the future of Coq development. Mm-hmm. And you also know that, well, there is a lot of Coq development written before, and sometimes it needs to be improved, right? Mm-hmm. Like there is maybe type classes unification algorithms which there are like 2 or 3 and they are all might be obscure or something like this. So if I understood correctly, there is also important mission to rewrite all those parts or to clean them up. Can you?
I think for the work on unification, I think it's a mistake that it was not mentioned in these slides. There is really an effort to reduce the number of unification algorithms in the system. So this is going to give fruits either in the next release or the following one. But there will be a simplification of the use of unification inside the Coq system.
And in more general, so there are a lot of effort will be spent to rewrite those parts of Coq which existed and should continue to exist in Coq development.
For now, I don't have the impression that any mission like that has been given. I think it has to be. There are places where the team is unsatisfied with the fact that there are parts in which it's a bit like the police don't go in certain quarters of the city because it belongs to the gangs. So it's a bit like that, and this is something we really want to avoid. And we are making progress on that thanks to the ability and time that people can spend on reading code. But because these people are mostly researchers, the benefit they can take on spending the time to just read the code has to be balanced with the time that they have. So sometimes some people like Mathieu, for example, have several projects in the works, and so the ones that produce new functionalities are often preferred on their timetable. But for example, one example of an attempt at simplification is that we are thinking of removing omega from the code. Because there's another development that's more recent and that's actually better. So now we have to think: is the fact that it is better is not enough? Is it better, and is the code readable? Do we know how to maintain the code? But in fact, it's already there. So we already have to maintain the two pieces of code. We have this thing that is called PSATs that provides the LIA and LRA tactics. So LIA is for linear integer arithmetics, and LRA is for linear real arithmetics. And these two work very well. The design principle is a little better. So having at the same time omega and the other one is questionable. So one of the efforts is to remove omega. So in fact, we don't have only two solutions for this problem. Well, we have three, because there was also an attempt to redevelop omega in a reflexive manner. So there is something that is called R omega, but who in this room has already used R omega? Once?
Just to see if it existed.
Yeah. So this is the example where sometimes you have to be careful with how you handle problems just for human reasons. You know, the person who invested on making R omega does not really understand why we would remove omega, and the preference of going to some code that is quite hard to read when compared to R omega, which is Galena code mostly. But the fact that it is Galena code really makes it easier to read? Yes, in this case. Other question? Sorry.
So are there attempts to make a tactic system that's more debuggable in the sense that you can step through particular subtactics being applied? And is there a plan to introduce something sort of like Sledgehammer from Isabelle or Chapalo's crush tactic into the standard?
So these are two different questions. Maybe I should have repeated the questions as the other speakers have done. So the first question was, is there a plan to have more debugging facilities in the tactic languages? And the second one was?
Is there a plan to introduce something like Sledgehammer?
Sledgehammer. Okay. So the second one was, is there a plan to introduce a system like Sledgehammer that takes benefit of proofs done by all the tools and then reintegrated in the system, in the Coq system? So.
Someone is writing a paper about that, right?
Yes, so let's talk first about the debugging facilities. I don't know. There is already a tactic debugger for LTAC, and I don't know what is the debugging facilities for LTAC2. I don't know if if something has been thought of about it. I also heard this week that people would like to have a debugger just for Galena code. And funny enough, we never made an effort for this, because if you want to debug your code, you just make a proof. But I think it's really useful, because sometimes, as was also said by one of the speakers, is sometimes the code you write is the specification. So you want to be able to know exactly what this specification is doing. So we have to do something about this. But I can't say who is going to work on it. As I said, I won't be able to answer to all the questions. For the Sledgehammer idea, there is an effort that's been developed that's called Coq-Hammer. So I don't know if it's so close to an answer. There is also, the same people are also working on using more artificial intelligence to understand what parameters should be given to the automatic tools to improve their chances of success. So that's one aspect. The second aspect is that we also have an experiment that is that is dormant. That is, there is a SMT Coq system which actually organizes the connection between Coq and an SMT solver with a reintegration of the proofs inside Coq, so that in the end what you have is not a proof that is shared by the Coq and the SMT tool, but a proof that has been completely verified by the Coq system. This experiment, the last working version is for Coq 8.6, and we are waiting. So it needs to be ported on a more recent version of Coq. It's waiting for the native compute development to be completed for Coq 8.8. So there is an intricacy of dependencies that makes it slower to integrate. But basically what I hope is going to happen is that the burden of maintaining this piece of code is going to be transferred from the initial contributor to the Coq development team, and then we will be able to maintain that in the long run. So I hope this is a solution. There was another question.
So just a comment referring to what you said about this direction of using machine learning to try to restrict the amount of lemmas that is given to those automatic improvers. So Jasmine Blanchette, like the developer of Sledgehammer for Isabelle, told me many times that it's very impressive how far one can go by using some very trivial heuristic to restrict to a few hundred, maybe 1,000 lemmas. And, like, just something very stupid, just say, okay, all the identifiers that are used in my numeric theorem, I will just take all the lemmas that have that and then send them to the improver. And he says that it's impressive how far one can go with just something as simple as that.
Yeah. We're somehow attracted by complexity, and simple solutions are often amazingly strong. Thank you. Another question? So I hope you're all satisfied with your usage of the Coq system. If there is any improvements that's really obvious, don't hesitate mentioning it. Because of Leonard, you gave me a round of applause, but the round of applause is not for me; it's for the 10 people who were on this slide. The reason I'm here is that I was ready to travel. I don't have babies in my family, and I think Mathieu has been out of his house for most of June and the beginning of July. So Maxime, as I said, is really busy. So I was the one ready to come, and I'm really excited to see all the beautiful things that were shown here. So thank you for all of you too.